Did you know that solar panels actually produce less power when they get hotter? You might think a hotter panel should generate more electricity, but in reality, excessive heat actually makes solar panels less efficient. And in this video, we will explore why that is. So before we start, we have to ask the big question. Why does electricity gets reduced in solar panels when they get hotter? Now, naturally, as we said, we might think the opposite is true. When the temperature is higher, any typical person would assume it would produce much more power because the sun is stronger. So now we will get into into a little physics and explain why that is the actual opposite. So the first thing that we have to understand is how the material that makes up solar panels behave. And these are called semiconductors. So what semiconductors are, you can think of them as behaving in the middle between conducting material and insulating materials. So those that conduct electricity and those that do not conduct electricity. So they are in the middle. So every solar cell is made up of these semiconductor materials, and they're usually silicon. So when sunlight strikes the solar cell, as we see in this photo, the energy from the sunlight is transferred to electrons inside the silicon material. So these energized electrons begin moving from the energy of the sunlight. And this creates an electric current that can be used to eventually power basically devices, your homes, or whatever. You can think of it as the output of the solar panel. So that is our focus here. So the focus is that sunlight begins moving these electrons, and then these electrons will transfer to the load. Now, at the same time, we have what's called holes, and these are, you can think of them as uh, the opposite of electrons. So electrons is the negative side of the solar panel, and these holes are the positive, and this is typically found in any semiconductor material, not just solar panels. So the stronger the sunlight, the faster the movement of the electrons and the holes. And when these move fast, the electrons and the holes, we get what's called a potential difference or a voltage between them, a high voltage. So a higher sunlight gives is proportional to a higher voltage, and that's why in solar panels we have negative side, which is the electron side, and the positive side, which is for the whole side. So generally speaking, as we said, more sunlight means more electrons are energized and more electricity can be generated. But at the same time, sunlight doesn't just provide energy, it also provides heat. So right now we were talking about the photons, the energy in the sunlight. So now let's get to the heat. Let's see how heat affects specifically the electron flow here. So now let's talk about the heat from the same sunlight that transfers the photons to the solar cell. We also have the heat. So as temperature rises, the electrons inside the semiconductor in the solar panel gain additional thermal energy. So these electrons, even though they gain energy from the photons of the solar light, they also gain thermal energy. Now, at first, this might sound beneficial if you think about it naturally, but no, there is a problem to it. A problem that will cause these electrons to begin moving more randomly. So, if we have an ideal scenario where we have ideal temperatures, the electrons would move. You could think of it in a straight line, or in an organized matter. But when thermal energy is added, that movement makes it harder for electrons to flow in one direction. And this random disorder makes it harder for the solar cell inside the solar panel to convert the sunlight into useful electricity. So basically, you can think of it, whenever there is an increase in thermal energy, more chaos occurs, more disorder, and this reduces the efficiency of the solar cell to convert that sunlight energy into usable electrical energy. So in essence, this is the primary this is what happens inside the solar cell whenever heat increases. It all goes back to that it's disorganized. So we said that temperature or thermal energy causes electrons to behave in a disorganized fashion. So let's look at this in this graph. Basically, as temperature increases, basically this summarizes the behavior of how the voltage would be produced in any typical solar cell. So as we said, the biggest effect of temperature is a reduction in voltage, and the relationship between voltage and temperature. So as solar cells become hotter, the voltage produced by each cell in the solar panel decreases. Now, the current may stay relatively similar, but the voltage will drop. And this is a linear relation. So, whenever the temperature increases, the voltage proportionally decreases. And a lower voltage means lower output power that the solar panel can transfer to the load, or the power that the load can use. So, even if the sunlight is strong, even if the sunlight energy is ideal, if the temperature is high, we're going to see this relationship where the voltage will drop with an increase with the temperature from the sunlight. So one thing to also keep in mind is that not all sunlight reaching a solar panel is converted into electricity. So only part of that energy becomes useful electrical power. So let's say even if the uh, the weather has ideal conditions, like it's a suitable temperature, even from that sunlight alone, that will also slightly heat up the solar cells, and this causes the panel temperature to rise. And this is why, in whenever we're designing a photovoltaic system with solar panels, we have to consider a good design for airflow and ventilation. Because even if you add on high outdoor temperatures on top of the heat that is generated from the solar rays, you're gonna have a poor production or output from these panels. So it's important to also consider installation methods. And if that installation method is correct and does not trap heat, as that can make the panel even hotter and reduce its efficiency. So now we understand the physics behind why solar panels lose efficiency when heat increases. So this leads us to also learn that this effect is so significant that even manufacturers, so solar cell manufacturers, they include what is called a temperature coefficient on every solar panel data sheet. So what this data sheet tells us is basically most solar panels lose roughly 0.3 to 0.5%, depending on the manufacturer, of their power output for every degree Celsius that increases above the ideal temperature, which is 25 degrees. So that means a panel operating, for example, at 65 degrees may cause a reduction in 20%. And as you go even higher, uh, the efficiency is also reduced. So this is why, for example, PV systems that are built in North America are more, or Europe, are more efficient than PV systems that are, for example, built in the Middle East, because the Middle East has an average temperature higher, that is hotter climate than North America. So the energy output in these colder climates, they are actually better than the Middle East because of these temperatures. So, and this is where, as we emphasized earlier, hotter panels will reduce the efficiency of the output of these solar panels. And these are typically found in every data sheet of every solar panel that is that is uh, that is added by the manufacturer. So the main takeaway that from this video is that solar panels don't just care about sunlight. They care about the temperature too. So as we said, more sunlight generally helps, but excessive heat will reduce the voltage and lowers the efficiency. And as we've seen, because this leads to a disorderly behavior of the electrons in the silicon material of the solar panel. And that is why a cool solar panel will often produce more power than a hotter one, receiving the exact amount of sunlight. Thank you for watching this video. I hope you enjoyed it. If you want to see more videos related to electrical engineering, power systems, electronics, and renewable energy, please like, share, and subscribe.